Bobcats, you're watching the second part of our variation functions videos. This part is about inverse variation, and by the end of this video you should be able to solve problems involving inverse variation. Once you pause the video, go ahead and take down these notes. Inverse variation is a relationship between two variables in which there's always a constant product, k, so x times y should always equal k. You always see inverse variation functions written in this format: y is equal to k over x. K is that, of course, constant product. Sometimes in word problems you'll see it written as y varies inversely as x, or y is inversely proportional with x. All right, and to illustrate that, we have kind of a real-world problem here. If we look at this table, we have time, speed, and distance. And you should notice, if we take our speed and multiply it by our time, we get 600. Same thing if we do 40 miles per hour and 15 hours of traveling, we get 600. 50 miles per hour, 12 hours of traveling, we get 600. So we have two variables here, speed and time. They always result in a constant product. So this is an inverse variation situation from the real world. All right, so here's an algebraic situation. They say that y varies inversely as x, and y is 3 when x is 8. So write and graph the inverse variation function. All right, so first of all, we need to find the constant of variation, the k. So remember, x times y should equal that constant. So we know that x is going to be 8, y is going to be 3. So 8 times 3 is equal to 24. So we know that k is 24. Now we can write that inverse variation function. Remember, inverse variation is always written in the form of y equals k over x. So in this case, our equation that we're going to use is y equals 24 over x. That's our equation. All right, but now they also want us to graph it. So to graph it, we want to come up with a table of data values. And of course, it's important to note that when we're graphing inverse variation, we want to choose values for x that are factors of k, so that we're going to get values of integers and not fractions. All right, so for instance, let's pick the number for x and y. Let's pick -3. When I plug in -3 to this equation, I get back out a -8. When I pick out -8, I would get -3. When I plug in -8, I get -3 back out. When I plug in -24 into the equation, I would get -1. When I plug in 6 into the equation, I would get out a +4. When I plug in 24 into the equation, I get out a +1. Let's just do a couple more. When I plug in 12, I would get back out a 2. When I plug in -2, I would get back out a 12. -12, excuse me. Also important to note, watch what happens when I plug in 0. If I plug in 0 into this, 24 divided by 0, that's undefined. So we can't have that one. So now we want to go ahead and graph this. We want to choose an appropriate scale. So let's count by 6s, which means this would be 6, 12, 24, 12, 24, -12, -24, -12, -24. And let's plot our points. -3, so if we're counting by 6s, -3 would be right here. Then we go down -8, so right about there. -8, this is -6, here's -8. And down 3, so right about there. -24, down 1, so right about there. Oh wait, excuse me, not right there. Right about there. +6, +4, so right about there. +24, +1, right about there. +12, +2, right about there. And then -2, -12, right about there. So as you can kind of see, we didn't pick enough data values, but if we need a lot of them, if we had continued picking more valuable variables, we would have wound up seeing we got a function kind of like this, or a graph kind of like this. So there is our equation. Of course, it's important to note that, hey, we never actually did get to 0. We'll talk more about why that is in upcoming lessons. So why don't you guys try this one? All right, one more. Well, actually, before we get into that one more, let's take a look at this. This is telling us another way to look at things. We know that y is equal to k over x. So one way to think about this, in situations where you have, it's inversely proportional and you have 2 x's and 2 y's, you wind up with this special kind of pattern that's going to happen. So if you know that k divided by x1 is y1, well then you know that k is x1 times y1. Same thing if you have a second situation, if k divided by x2 is y2, then you could say that k is also equal to y2 times x2. So then, since this is equal to k and this is equal to k, you can use substitution and say y1 times x1 is equal to x2 times x2 times y2. So we'll look at why that applies in this word problem here. It says the time that it takes a group of volunteers to construct a house varies inversely to the number of volunteers v. If 20 volunteers can build a house in 62.5 working hours, how many volunteers would be needed to build a house in 50 working hours? All right, so key word here that told us this was inverse variation was varies inversely. We know that the time it takes the workers to construct the house varies inversely with the number of volunteers. All right, so we know that time times volunteers will give us our constant. Time times volunteers will give us our constant. We know that if we have 20 volunteers building a house and it takes 62.5 hours, how many volunteers would be needed to build a house in 50 hours? So we know that we have 20 volunteers and they're going to work 62.5 hours. So, and that's going to give us our constant. So that means that our constant of variation is 1,250. 1,250. So in other words, our equation for this situation would be y equals 1,250 over x. So now we can solve this. We know that if we're going to, how many volunteers are we going to need if we have 50 working hours? All right, so in other words, if we have 50 is equal to 1,250 over x. So we would multiply by x. We get 50x equals 1,250. Divide by 50. X is 1,250 divided by 50, which is 25, which means we need 25 volunteers. All right, to look at this using this through this lens, we can solve this another way. We can say, since we know that they're inversely proportional, we could say that 20 times 62.5 should be equal to 50 times the number of volunteers, which we don't know. So again, you're going to see kind of a lot of the same work that we just did. 1,250 is equal to 50v. Divide by 50. And again, you see that v is 25. So kind of another way to work that. It took up a little bit less work. Here, try this b involves that problem that we just finished. So here it is again if you need to refresh your memory on what those words said. We will see you in class today.